Okay, all right. So let's talk about some battery math as it relates to state of charge. And you might be wondering what state of charge is. Well, a battery has a charge and it's at a certain state. Let's say this is at 10% charged, so it's going to have a 10% state of charge. Likewise, this battery on the right hand side looks like it's charged up to 60%, has a 60% state of charge. Easy, right? But you might have noticed that when you buy electronics, in this case iPhones, all the charging metrics that they cite is up to a certain state of charge. All of these down here, down here, down there, are giving you a quote based on a 50% charge. 50% charge in 30 minutes. 50% charge in 30 minutes. Why is the quotation from 0 to 50%? Do you want your phone half charged? You probably want to charge your whole phone. Isn't that kind of annoying? How long does it actually take an iPhone to get to 100%? Why doesn't Apple tell you? Well, it's because battery chemistry is weird. So let's get into this. It also applies to Google phones. So for Google Pixel, they're talking about 7 hours of battery life in 15 minutes. How much battery life is 7 hours? Is that 10% of the battery is going to give you 7 hours? Or what have you? Who knows? What 7 hours mean? 7 hours means nothing in terms of state of charge. It doesn't mean 0 to 100%. It doesn't mean really much of anything. So they're being intentionally vague because it's actually kind of a curve. And we'll see that also for Tesla. So Tesla has, um, you might not have heard of them. They make electric vehicles that, yeah, they're okay, I guess. And you might have noticed that they have superchargers, which are apparently fantastic. But one thing that's strange is for all the quoted charging times, they'll have increments that are different speeds. So you might have from 9 to 50%, 12 minutes, 9 to 60%, 15 minutes. So you have a 3-minute hop here, but to get to 80% to 90%, it ends up being a 10-minute hop. So it's more than twice as fast to charge at this level, at the 50% state of charge, than it is at the 80% state of charge. And for probably related reasons, Tesla's limiting superchargers to 80% because at 80% things get really slow and they don't want you parking in the supercharger spot, I suppose. And maybe related to battery chemistry, for the sake of efficiency and longevity of the battery, you have the CEO of the company saying that you probably shouldn't charge past 90%. And it's not only this electric car, it's also, oh, hang on one second. Here's the same data in a chart. So you have a customer that used the new supercharger version, and then from here at 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 a given state of charge, 10%, 20%, and so on, they have how many kilowatts of electricity they're managing to gobble up. And if everything was all equal, like if charge is completely linear, then this would be like a straight line. And that's what you would want. That means it takes from 20% to 30%, from 70% to 80% would be a state of charge with that took you an equal amount of time to charge. But you can see at for the Tesla at 45% or 50% or 60%, you end up hitting different inclines, and the rate of charge drops significantly. And then this last hop takes a lot longer than the first this middle did. So let's get into this for other vehicles. The BMW i3, same thing. At a certain state of charge, the rate of charge drops. An IONIQ. I guess it's a vehicle as well. 80% state of charge. Your charge rate, your charge speed takes a big hit. Same thing with the Nissan Leaf. 80 at different, um, let's say models of vehicle. I'm not sure. You have different drop-offs, but you can see after 80%, it's not so good. The charging rate basically sucks. Now, I don't have any of those vehicles, but I do have a ridiculous electric skateboard, and it's got a charge port here, right there. And it does have an application that will give you a charging time estimate. So I plugged it in. I'm at a 69% state of charge, and it's giving me a 33-minute estimate. And I also hooked up this thing to tell me how long or how many watts I'm eating up at any given time. And then given these 3 data points, I can tell you for sure that this estimate is terrible, right? This is just bad. But yeah, and then I made a chart. So the chart is like this. So here, the remaining seconds, and here is my state of charge, state. And this remaining seconds is what the app is actually telling me. And you can see that the remaining seconds chart is actually tracking for a long time the remaining time to 95% charged, not 100% charged. And after a certain point in time, the time estimate becomes ridiculous and unreliable. Like a 95% charge, it ends up being flat line, which means the time estimate's not decreasing. And if you look at the wattage chart, you can see why. Because at the 82% state of charge, the charge rate drops like crazy. Once you charge past 82%, you're not getting your regular 220 watts, right? So if you charge past 90%, 90% to 100% is going to take a lot longer than 70 to 80% took. So what should the application do? Well, this time estimate, instead of saying 33% to 100%, or 33 minutes to 100%, it should probably say 15 minutes to 85%, or something reasonable. And then what that would mean is at 85%, you know that you may as well unplug and do something else, but and not waste your time trying to get that last 15% of charge at a terrible rate, because this metric over here will be at, let's say, 100 or 70 watts instead of 222. So yeah, basically you could spend your time more wisely. Okay, all right.